Ever wondered why AI is literally undefeatable in any turn-based game like chess, Connect 4, Tic Tac Toe? Well, in this video I'm not only going to figure out why, but you are going to code your own undefeatable AI algorithm. The best you can do is end the game as a draw with him, but he is undefeatable. We are going to use an algorithm known as MinMax search algorithm, which is very powerful and very easy to learn. So if you are beginner to AI trying to learn what AI is and get into the field, or you just want to learn what MinMax algorithm is, this video is for you. We are going to code everything in C#, but you can code it in any language you want, so feel free to follow with stuff like Python, JavaScript, and so on. Without further ado, let's get started. First start by making the XO environment for our agent. So we will start by, and we will make this quickly because it's not the main focus of this video, so feel free to skip this part if you want. But we'll start by 2D array of characters. Let's call it board. And okay, so each one would have 3 columns, and we'll repeat this 3 times. Yeah. Okay, now I need to make a function play move, and it will take an integer of position, and it would return a boolean of whether this move was valid or not. Okay, so let's turn it true for now. Anyways, how will we place position? If the player entered the 0, it will place here. If entered 1, it will place here, and so on. So I think the best thing to do is to create a dictionary for and hard code all the possible values. I mean, this is a small board anyway, so this will be faster in terms of performance, and it will just be like this, and I will have at position 0 it will be at 0 0. I will just do the rest and be back. Okay, good. Now for the play move itself, we will check if the move map dictionary does not contains key position, then we would return false, as this is not even a valid position. Oh, we also need to take the board as well. So now we'll check if actually, let me make a symbol for both the bot and the player. So let's make it static car bot. Let's keep it as X, and static car player is equal to O. Okay, good. Now we need to check if the board at this position is available. So let me just a table of integers. Position index is equal to move map at position. This would be basically a table of, say, 0 0 or whatever our position is. And now we do if board at position index dot item 1 at position index dot item 2 is not equal to an empty space. This means that it's already taken, so we would return false as well. Good. Now we need to play our move, so let's first take whose turn this is. So character turn, and we'll just do board at position index item 1. I'm pretty sure there is a better way to do this, but I'm too lazy to search for it. Anyways, we're just equal to turn, and we're done. Now we need another thing to check who won, so int check winner. So we need the board, of course, which is a double array of characters. Yeah, that's the only thing we need. So let me put a few comments here. So return 1 if bot won, return a -1 if player won. This will be used when we code our AI, basically, like, so our AI knows what is a good score and what is a bad score. Anyways, so we would return 0 or none. I would take this to ChatGPT and let him fill it, honestly, because again, this isn't the focus of this video. So fill the check winner function, please. Now let's place what he gave me, basically. Good. Now we need to make our infinite loop. So while true, actually let's initialize a turn first. Let's keep the player be the one to start. So at the end, if turn is equal to player, turn is gonna be, if turn is players, then I gotta switch it to bot, otherwise I will turn it to player. Now I just need to take an input from the user, so dot read line, and I'll just do parse int to parse read line, read line tur move, and I'm just gonna do int move is equal to, and then I just pull valid is equal to, oh, I need to turn this function into static so I can use it. So static, and I need to turn this to static. What is the issue here? So I just need to make this static as well. Okay, good. Now I can use my function here, play move, and I'm gonna just, let's call this position. I'm gonna pass here's position, and we're going to pass in support, and we're going to pass the turn as well. Okay, if not valid, then continue. Or before we continue, I just, let's console right line, valid position. Okay, we need to make a function to draw the board as well. So static draw board, which would return void that just takes a character of board, and we need to draw the board like once here, give it the board, and then after the player is done moving, so draw board, give it the board, and let ChatGPT fill this as well. Okay, let's replace, and let's first test that our environment works correctly for now. Wait, I just realized I forgot to check if I got a winner here. So here we place a move. If it's not valid, then we draw the board, and we need to do here int winner. Actually, let me adjust it here. So int winner is equal to 0, and while winner is equal to 0, and here I just need to update the winner. So winner is gonna be equal to check winner, check winner. Give it the board. Okay, and at the end I'm gonna also try line 1. Now let's test our environment. I'm gonna try to play an invalid move at 0. Okay, good. So I'm gonna play at 2, then I'm gonna play at 8, and a -1 because the human won. Okay, now our environment is done. For the next part, we're going to code the AI algorithm itself. But first, let's discuss some theory on how the AI would work. How will our AI basically figure out what is the best move? So let's take a little XO board, for example, and just say it is X turn to play, right? So we have a lot of options. So X can either play here, or X can play here instead, or X can maybe play here, right? And the same goes on for the rest. What if X played at this pass? It is now the O turn, right? So O as well have multiple options. He can either, like we now have an X here, O can play his O here, or he can play his O here instead, right? So he could place his O here instead, and the tree keeps expanding on from all sides basically for every single possibility. And say that sometime very late in the tree we have, like it kept getting branched and branched, and then some branch was just here and it had multiple options. So let's say that here X made a fatal mistake and O was just sitting like so, okay? And now it is X's turn to play. So whatever X does, he is going to lose the match. So if you reach it here, your score is always going to be -1 because the player won, so the AI will get a negative score. So the AI tries to avoid this branch as much as he can. Let's say that somewhere, like if he made this choice instead, and somewhere later in the tree x was sitting in this position, so he had an x here and x here, and O was like here, and now it is O turn to play. So no matter what O does, he's going to lose. If he plays an O here, X is going to just do here and he won. If O went here, X is going to do here and he won as well. The thing is, here the AI won, right? So this would return a 1 as it is a positive reward. The AI tries to reach to this point. But here is the thing. Like here it is X turn to play, but here it is O turn to play. X would try to reach this, but O will try to avoid it as much as he can. O instead would try to reach this area where he can win. So what will happen is that when it is X turn to play, it will try to maximize the reward. It will try to search for the reward that gives him the positive one. And when it is human turn to play, he will try to minimize the reward he gets. So he will try to avoid this branch as much as he can. He will try to, I don't know, search for another branch that would give him a negative one instead, so it is O that is destined to win basically. Or maybe he will try to search for a branch where it is a draw, so it would be a zero to be returned. Like O will do this if he can't find anything with where he can win basically. As you can see, this will get very messy fast, so let's try to visualize it better through this tree. So let's assume it is X turn to play here, and here it is O, here it's X, here it is O. And we went down to the very depths of the trees, and here we see that this would return a -1. So -1 means that O won. So say it was a position like this where O won, you know. And here it is a 1 where X won instead of O winning. Now it is X turn here. Which would he pick? Would he pick something that would make him lose, or something that would make him win? Of course, something that would make him win. So this has a value of 1. How about here? Well, both are zeros, so X here doesn't have a choice really. By the way, 0 doesn't mean that the game ended as a draw. Like, it can be either means that the game ended as a draw, so there are no possible moves, or there are further branches to be explored. But since the tree expands like very heavily, we usually limit our depths. So here we are limited to seeing only 3 further actions, or otherwise like it would take really lot of time to compute. Anyways, here it is X turn to play, so he would choose the 1. Here it is X turn to play, so he would choose the 0 because there is no other option. Here it is O turn to play, so O of course wouldn't want X to win, so he would choose this pass instead, resulting it having a value of 0. And here it is O turn to play as well, so he would have a value of 0. Here it is X turn to play, so he would choose any of them randomly, so X here has the value of 0. And this could be a bigger part of the tree, so maybe another part is where it would have a 1 instead. So if it is X turn to play here, he would try to go there, and if it is O turn to play, it would try to go there. So let's say that X placed his X here basically, like going with this pass. It is O's turn to play now. If O knows what he's doing, he will pick the best option and go there and end the game as a draw. But if O doesn't know what he's doing, he is a human like us, he may choose this pass instead, which would result in an X winning. So that's why X accounts that his opponent makes the very best possible move he can do. If he didn't make the best move, then X is going to win. Enough with the theory, let's start coding it. Okay, let's say make the MinMax search algorithm here. So void MinMax search. First of all, we need to have an idea of how our board looks like. So I'm gonna take a 2D array characters for our board. And actually, let's code it and think about what we need as we go. So for any recursive approach, it needs a breakpoint basically. So our breakpoint is if we have a winner. So int winner is equal to check winner with our current board. And if winner is not equal to 0, then return winner, and we are returning winner, so this needs to return an integer instead, so it would return the value of the node we are standing on. There is another case of a check if the board is fill, return 0, but I will do this later. Anyways, now we need to loop for each possible move. So our moves are from 0 to 8, so for int I is equal to 0, I is less than 9, plus I. Then we need to check if this move is valid, so if play move, here we need to take the position which is the I, and give it support, and they give it a turn. And we are going to do a turn here, which is going to be a character of either the player or the bot. If this was not a valid move, then continue. Otherwise, if it was a valid move, then we are going to explore the tree after we made this move basically. So we're going to call MinMax algorithm again. And by the way, how C# works is like here I call play move function. It takes board and it basically calls it by reference. So here I am modifying the original board. So any modification here affects the board here, which allows me to further explore the board after making this move. Okay, if you are following this with another language like Python or JavaScript or whatever, then just make sure to update the board basically, so you can like here return a board instead, and just do here board is equal to play move at like after making your move, you know, just so it's worth pointing out. Anyways, back here we need to pass in the board and we need to pass in the turn. The thing is we need to flip the turn, so if turn is equal to player, then it is bot turn to play, otherwise it was bot, so we need the player to flip. Also we need something else here, we need a depth, which is an integer. As I told you, if we just let the AI explore every single branch, he would take a lot of time, so we are going to limit him to some value, and I'm just going to give this value, subtract 1 from it. So like say I'm limited to 3, so if I'm here I'm still 3, then I'm 2, I'm 1, I'm 0, and I stop. So I need to add this as a stopping condition as well, or depth is less than or equal 0, then return winner, and this would return int score basically. Okay, before I continue I just need to invert the move here basically, so I'm just going to do board at, then I'm going to go to my move map at I dot item 1 at move map I dot item 2. I'm going to set it to an empty space. Now I need to keep track of both my best move and best score possible. Okay, so what is a best move or best score? If it is the bot turn, he's trying to maximize, so my best is the maximum score. If it is the player turn, then my best is the one that minimizes the score. So I'm going to just initially make a best score and best move. So assume for now it is the bot turn to play. Okay, so we're going to set this to negative, a really large number, and the best move we are going to set it to being -1. Since we are trying to maximize, so we're going to do if a score is greater than best score, which is always going to be the case because we even if this return a -1, it will be larger than -999. So this is the first one is always going to replace this. So we're going to do best score is equal to score, and best move is equal to I. But the thing is, we're assuming this is the bot turn, right? So this is if turn is equal to bot. We're going to do this. But otherwise, if it was a player turn instead, then we're going to, it will be the same logic, but instead we will have a less than sign. And instead of best score being at a very large negative value, we need it to be a very big value. So we are trying to minimize the score here. So I'm just gonna do a little turn here. If turn is equal to bot, then we are going to set it to -999. Otherwise, we are going to set it to 999. And then instead of 999, I'm instead going to use infinity. So here int dot min value, so like the most minimum value an integer can hold, and here we will do int max value. Like AI developers usually use negative infinity or infinity. instead of really large or small numbers to be more flexible. Okay, so after we are done, we need to return a tuple of basically the best score of the position we are on for now and the best move. And here I need to just edit this to be a tuple of integers instead, the first one being the score and the second being the move. And here we are returning a winner, so here there is no move to be made even, so we're just going to return -1. And what's the issue here? Oh, we here need both an integer for score and then take an integer for move. But the thing is, the move we got from here is not the move we made. It is like the best move from this position. It's basically what this returns. So I won't really use this for anything, so I'm just gonna keep it as underscore. So here's the thing. Remember when I told you to check if the board is filled? Well, we are technically doing it here. Here, if the move is not valid, we don't do anything, right? So let's take, for example, we had this case. And the AI tries to play. So he tries here, no. Here, no. Here, no. Still not valid, not valid, not valid, not valid, not valid, not valid. So the AI says that there is no option to make. So basically nothing here happens. This case means a draw. So if best move stayed at -1, then this means this is a draw. And as you know, a draw has a score of 0. So if best move is still -1, then I'm going to return the best score being a 0 and the best move being a -1. Otherwise, we're going to return this. Or I could do a simple ternary operator of best move is equal to -1. Then I'm going to return 0. Otherwise, I'm going to return best score, because I don't want to return an infinity or negative infinity, of course. Like I want to return a 0 because this indicates it is a draw. Okay, I think this is done. Now we just need to test it. So if turn is equal to player, then we allow the player to play. Actually going to do int position here. Just go. And if it is not the player turn to move, then it is the AI turn. So I think I forgot to, I need to make this static so I can just use it. MinMax search. We're going to give it support. We're going to give it the turn, and let's keep the depth 5 for now and see how it goes. So this would return two things basically, so a score and a position, right? We are not interested in the score. It is something completely for the AI, so we're not going to take it. We just are interested in position. And before I continue, I need to check for the case of draw basically. So let's make a function here. Static bool is draw. I need to take a character of the board, and for int I is equals 0, I is less than board of length plus I. For int j is equal to 0, j is less than board dot length, board at 0 dot length this time, plus j. And let's make a variable of bool is full. Let's assume it is true for now, and we would return is full. And here, if board at I at j is equal to an empty space, this means there is still a position, so we'd return false directly. Otherwise we can return true actually, and we don't need this variable. We can further simplify things down. Okay, and then here when we check for the winner, if actually instead of is draw, I think I should rename it to is full instead. So if the board is full, then we are going to break. Wait, let me try to make this look cleaner. So console.writeLine, just do a bunch of equals there so it looks better. So I am a human, I am going to be O, and the I is going to be an X, and I made it that the human starts first. Okay, so let's go with position 0. So the AI chose to place it here. I'm going to go with, wait, I think I actually won. If I go with 8, oh no, I didn't win. He caused us a draw. Hello, me from the future here. I just wanted to point out that from this position, the AI could be defeated. So if I just placed an O at this position, then the AI will lose no matter what. So here he made just a choice,
a random choice because every single choice from here is him losing. If he plays an X here, I will just place an O here, and either this or this, so he can't stop me. And if he doesn't, then I just do it here and win basically. Oh, I made a wrong move, but you got the idea. So what made the AI make this wrong calculation? I really recommend you to pause the video now and try to think about it yourself. And a little hint, it is something related to the depths exploration. Here we give him a depth of 5, okay? And thing is, we explore the board from whatever its position is, then we perform a new move, and then we check min-max again, but here depth is -1. And when depth is less than 0 or equal to 0, then we just stop, right? So if we trying to visualize, so I have X here, then I call my min-max algorithm with a depth of 5. So at this situation of the board, our depth is now 5. So we explore each move. So say one of the moves was this, and after we play this, we call min-max again. But now instead of 5, it is a 4. And with this board, so now say the X plays here. Again, the AI is accounting for all of those possibilities. So, and from here we need to explore further. So now we are at 3. Let's say O plays here because this is the only options that want to make him lose. So now from here we explore with depth of 2. X plays here, so now we explore with depth of 1. O plays either here or here, so let's just play here, and we explore this board with a depth of 0. What happens when our depth is 0? Exactly, we just return the winner, which in this case is 0 because no one won yet, and we return -1 because there is no move to be performed from here. So the thing is, since we limited our AI to just 5, he can't see what will happen further from this point. If I made this a 6 instead, he can see that I will do this and this pass will lead him to a loss. But and let me demonstrate this now. So let me change this from 5 to 6 and just run again. And here let me enter a 0, and you can clearly see that he placed it at a better position because there is now 6. So when he reaches here, he is still at 1. So he can see that X will do this, and when it is this state of the board, it is now the 0, but it doesn't matter because he already sees that X1 giving him a -1 reward. So yeah, so always make sure to choose your depths mindfully. Just wanted to show a little trick for MinMax search algorithm basically. So going back to our example here, so suppose we are still exploring, okay, and let's say that the AI algorithm instead explored it starting from this position. So I'm now at this position, it's O turn, so he explored this move before this, okay. So from here he can see that it is X turn, so you have either 0 or -1, so it is going to be a 0, right? So now O now knows that his best move is going to be this one of minimum is equal to 0. Now he starts exploring this branch, so he sees here that X have 2 moves, either -1 or 1. So X will first explore this one, for example, and he takes a 1 here. So here X is a maximum for now of 1. The trick here is that no matter what X will see, like say here I have another branch of 5, like if this wasn't an XO and there could be multiple values, it could be a 5 here, or it could be a -trillion, right, or a -10. The thing is, X will never pick anything less than 1, so even without further exploring the other branches, we can know that here is going to be +1. And well, always now have a choice between his global minimum of 0 and something else that would always be more than 1. So of course he would pick his global minimum of 0, and that's the idea. Will always pick this. So as you can see, we didn't have to explore this branch, we didn't have to explore its sub-children, we didn't have to explore any other thing. As soon as we saw this one here, we immediately stopped exploring this area. This idea is called alpha beta pruning, where alpha is the thing that stores your very maximum option, and beta is the thing that stores your very minimum option. When you are playing at X, you want to update this alpha because you will always choose the maximum, or playing as the AI agent. When you are the human, you are going to always update this beta because you are going to try to search for the minimum option. Let's see how it is coded. It's actually like really easy. We just need to add 2 lines here, I think, or something. So we just need to take the alpha and beta, and the same as we initialize those to infinity values, we will do this here. So we will initialize alpha as being n.min value, or negative infinity, and beta as n.max value. I mean, we could have passed those instead here, but I prefer doing default parameters, just me. Now, if this was the bot term, then we need to update alpha because we are only interested in the maximum value. So alpha is equal to mass.max between alpha and score. Okay. Now here comes the part that if beta is less than or equal to alpha, then we don't need to explore all the other possibilities. If this line is confusing you, let's recap it quickly. So here you are standing on the O. He sets his beta to 0. Here we are standing on the X, so the bot. So he sets his alpha to be 1. And before exploring the other options, we compare beta to alpha. Since O have an option that is better than our global maximum, O would always choose this without exploring this. That's basically what we are doing here. We just need to exactly repeat this here. It will still be the exact same condition if beta is less than or equal alpha, but here we just are interested in beta instead, and we need to take the minimum. And if you are confused on why this stayed the same, then let's go look back here. So it is O turn to play here, right? What made him play was the X. Say, just for demonstration purpose, this was a 1 here instead, okay? And we explored this branch first. So here we had an alpha being 1. We look at the other option, and O started exploring, and it sets its beta to be 0. Now since the beta is less than alpha, then the thing above us, which is the X, will never explore this option. It will always try to maximize its reward, so it will look here instead. Now back here, don't forget to pass in your new alpha and beta values, and just like that, your AI now performs way less operations and returns the exact same result. Thanks a lot for watching. If you learned something new, don't forget to like and subscribe. Stay curious and keep learning.